So here we're going to talk about transformations of functions. We're going to talk about horizontal shifting, vertical shifting, reflections across the X and Y axes, and then stretching and compressing. Okay, so we're kind of summarizing all the different transformations. So the first one, horizontal shifting. So horizontal shifting. So what does this do? This moves the graph left or right. Okay, left or right. Now, in general, we have some g of x is equal to f of x minus h. Okay, so the kicker here is that the shifting is done inside the parentheses. Okay, if your inside your parentheses is negative, so the h here, if it's greater than 0, we go to the right. So like this would be like an f of x minus 4 would mean right 4. And if I have h less than 0, we go to the left. So f of x minus 3 means I go to the left. I'm sorry, f of x plus 3 means I go to the left 3. Okay. So remember that minus minus we talked about in the other video. The horizontal shifting does the opposite of what you think it will do. So say I have f of x equals x plus 2 squared. What is this? This is a parabola that we take and we shift it to the left 2 units. And so when I shift it to the left 2 units, 2, 0 is my new vertex. Negative 2, 0 is my new vertex. Right? If I have another function and it's like the square root of x minus 4, what does that minus tell me to do inside the parentheses? I take my square root function that looks like this, okay? And I'm literally going to move it to the right 4 units. So this becomes 4, 0, or my starting point for my square root, okay? So the right inside has a minus and the left inside has a plus, okay? For the next trick, we're going to do vertical shifting. Vertical shifting moves the graph up or down. Okay, moves the graph up or down. So vertical shifting, if I have some g of x, it's equal to f of x plus some number k. And if k is positive, we go up. And if k is negative, we go down. Bless me. All right. So, an example of upward would be like f of x equals x cubed plus 1. So what would that graph of x cubed starts down here at negative infinity, wiggles a little bit, and then comes up to positive infinity. Okay. So I'm taking this graph, and what am I going to do with the graph? I'm going to shift it up 1 unit. So now where I cross here is at 0, 1. Okay? Now, downward would be like f of x equals the cube root of x minus 2. So what would that do? So a cube root function, right? Once again, it's opposite. So if one's going to negative infinity, the other one's going to positive infinity. So it looks like this. Okay. So what am I going to do with this? I'm going to transfer it down 2 units, 1, 2. And so if I transfer it down 2 units, now all of a sudden I'm crossing at 0, -2, okay, on the y-axis. So that goes to positive infinity, and that goes to negative infinity like this. Now let's talk about reflections, because reflections pop up a good deal. So reflecting with respect to the axes. Okay, reflecting with respect to the axes. So I've got 2 reflections I'm going to talk about. X-axis reflection. Okay, how does x-axis reflection work? It takes a graph f of x and it reflects it by multiplying the whole function by -1. Okay, so what do I mean by that? So say I have the function f of x equals x squared. So f of x equals x squared. If I multiply by -1, now that function comes down and reflects. This becomes negative f of x, which is negative x squared. Remember, the coefficient in front is positive here versus negative here. If it's a positive coefficient, I'm smiling, I'm concave up. If it's a negative coefficient, I'm negative in behavior, going down to negative infinity, concave down. There's a frown, all right? So how do I do this? To do x-axis reflection, I multiply entire function by -1. Multiply the entire function by -1. Okay, that's the key. So if I had like a f of x equals 2x squared plus 3x minus 1, then to flip it, I would multiply the whole thing across the x-axis. Remember, this is the x-axis. I'm reflecting across. It'd be negative 2x squared minus 3x plus 1. Okay? So all the signs change. All right? Now, with respect to the y-axis reflection, this is going to take f of x, the function, and everywhere I see an x, I'm going to replace it with negative x. Okay? So what do? I replace each x with what? Negative x. Okay? Always put your parentheses around it. I promise you it's going to help you out. So say you have the graph, okay, and your f of x is the square root of x. Now, square root of x only works for positive numbers. But if you replace x with negative x, then this becomes the square root of negative x, and now it only works if my numbers are negative. Why does it only work for negative numbers? If I plug that in, I get minus a minus 4 gets me positive 4, which gets you 2. You see why it works? The negative undoes itself. So what's happening? I'm reflecting across this y-axis. So values over here get reflected to over there. Okay, so now things that were positive now become negative on x values. Okay, so this is the key. Replace each x with a negative x for y-axis reflection. Now, stretching and compressing. This is the last of the transformation ideas here, and then we're going to do an example where we put it all together. So stretching and compressing vertically. Okay, stretching and compressing vertically. So if I have some function g of x and I multiply by a number times the function, if the number is greater than 1, then a times f of x is stretched vertically compared to f of x. Okay? So what does that mean? Right? What does that mean? So say we have some function. All right. So say we have some function. We have absolute value of x. Right? So this is the f of x equals the absolute value of x. Now, if I stretch it vertically, okay, maybe this function right here, this is my g of x, which is equal to 2 times f of x. So that's 2 times the absolute value of x. Okay, so it stretches vertically. So 2 is greater than 1, right? Okay, so it stretches it vertically. So this technically could work in absolute value here, all right? Absolute value, because you could also stretch it vertically and then do it in the negative direction. That's like -2 absolute value of x, right? So negatives also work. Now, say your a is less than 1, but greater than 0. Okay, then a f of x is compressed. It's compressed vertically. So these are the words you're going to use. You're going to stretch vertically or you're going to compress vertically. If a is greater than 1, you stretch vertically. If a is between 0 and 1, you're going to compress vertically. That negative we're actually going to take care of in the reflection process. So depending on how we're reflecting. And so if a is between 0 and 1, then I'm compressed vertically compared with f of x. Okay? So an example of this, say I have the graph x squared, so f of x equals x squared, and then your g of x equals 1/2 f of x, so that's equal, let me write that, so that's f of x, which is equal to 1/2 x squared, so that looks like this here. It's just compressed vertically. We're literally taking our graph here and we're compressing it vertically. Okay, so I can't really compress it with that operation, but you see what I'm saying. It pushes it down. Okay, so it's pushing it down. All right, so that kind of summarizes all the transformations.